Hi everyone, in the subject Physics for Electronics Engineering, today's topic is from Unit 1 Laser and Fiber Optics, explaining about numerical aperture and acceptance angle, and we are going to find the expression for numerical aperture and acceptance angle. What is an optical fiber? It is a material medium made up of glass or plastic, and the three important parts of optical fiber is core, cladding and the outer protective layer. Core is the innermost part of the fiber. It is surrounded by a cladding material, and then finally there will be a protective outer layer. Now we are going to see in what way light enters into the fiber and then undergoing total internal reflection for effective communication. Consider an optical fiber is taken and it is kept in the air medium. Let F dash be the fiber axis, X, Y is the interface between air medium and the fiber medium. Then X dash denotes the interface between core and cladding. Let the refractive indices of air, core and cladding be N0, N1 and N2 respectively. Consider a light ray AO which travels from the air medium and it falls at the XY interface at O, and then it gets refracted. It gets refracted into the core medium and it falls at the core cladding interface. Then it traverses along the interface. I repeat it. A fiber is kept in the air medium of refractive index N0. The refractive index of core is N1. The refractive index of cladding is N2. Let F dash be the axis of the optical fiber. There are two interfaces we are taking into consideration. One is XY, the interface between the air medium and the fiber medium. X dash is the interface between core and cladding. Here the refractive index of core is taken slightly greater than the refractive index of cladding. So then the light can undergo total internal reflection. But here the point is light travels from the air medium AO, then it falls at the XY interface, it gets refracted, the angle of refraction is theta r here, then it travels in the core medium, then at the core cladding interface it travels along the core cladding interface. So the propagation of light ray is explained here. Now let theta naught is the angle of incidence made by the light ray at the XY interface. Then theta r is the angle of refraction made by the light ray in the core medium. Now look at the diagram. Here, if this is theta r, the alternate angles are the same. Therefore, this is also theta r. Now, look at this point. It is 90 degree. If this is theta r, and the remaining portion will be 90 minus theta r. Then it travels along the interface. Then the angle of refraction here in the cladding medium is 90 degree. Now, in the derivation, we are going to apply Snell's law. At the first interface, at the point O, at the first interface, that is air medium and the fiber medium, the light ray makes the angle of incidence theta naught, and on the other side the angle of refraction is theta r. The refractive index of air is n naught. Here core is n1. So before the interface and after the interface, we are going to apply the Snell's law at this particular point. N naught sin theta naught is equal to n1 sin theta r. That is, n naught sin theta naught is equal to n1 sin theta r. Then taking n naught towards the denominator of RHS, right hand side, we get n1 by n naught sin theta r here. We know sin square theta plus cos square theta is equal to 1. Here we have theta r, therefore sin square theta r is equal to 1 minus cos square theta r. Therefore sin theta r is equal to root of 1 minus cos square theta r. Therefore in this way this sin theta r is replaced by 1 minus cos square theta r. Here we have n1 divided by n0. Now we have applied Snell's law at this interface xy. Now applying Snell's law at x dash interface, core cladding interface. Here n1 is the refractive index of core, n2 is the refractive index of cladding. Then angle of incidence made by the light ray is 90 degree minus theta r. Here the refraction is 90 degree. Therefore n1 sin 90 minus theta r is equal to, as given here, n2 sin 90 degree. Sin 90 is 1. Therefore n1 sin of 90 minus theta r is taken as cos theta r, which is equal to n2. Therefore cos theta r is equal to n2 divided by n1. Substituting cos theta r is equal to n2 divided by n1 in the first Snell's law equation, that is sin theta naught is equal to n1 by n0 into root of 1 minus cos square theta r. So cos square theta r is equal to n2 by n1 in the previous equation. Therefore cos square theta r is n2 square divided by n1 square. Taking LCM, we get n1 square minus n2 square divided by n1 square. Root of n1 square is equal to n1. Therefore this will be n1 divided by n0 root of n1 square minus n2 square divided by n1. We get sin of theta naught is equal to root of n1 square minus n2 square by n0. Since The medium in which the optical fiber kept is air medium. The refractive index of air is 1. Therefore, in the denominator, it is considered as 1. Therefore, sin theta naught is equal to root of n1 square minus n2 square. So, theta naught is equal to sin inverse of root of n1 square minus n2 square, where theta naught is called as the acceptance angle of the optical fiber. That is the maximum angle accepted by the fiber. So then the light enters into the fiber and it gets totally internally reflected. So here numerical aperture can be defined as sine of the acceptance angle, sin theta naught, sin theta naught. Numerical aperture denotes the light collecting efficiency of the fiber. The light gathering efficiency of the fiber can be given by this numerical aperture, root of n1 square minus n2 square. Acceptance angle, the maximum angle at which the light suffers total internal reflection. Now, what is acceptance cone? Consider the light beam falls at theta naught on one side of the fiber axis and theta naught at the other side of the fiber axis. Then together, like a cone, 2 theta naught angle will be there. The light rays or the light beam enter into the fiber and then it will be totally internally reflected. This angle 2 theta naught, twice the acceptance angle, so then it forms a cone shape here. It is called as the acceptance cone. This cone is called as the acceptance cone. So here in this derivation we have seen the numerical aperture is equal to root of n1 square minus n2 square divided by n naught. Since air medium is there, n naught is considered as 1. If the optical fiber is installed in or taken in any other medium, then that should be replacing this n naught. Then what is theta naught? Sine of the acceptance angle is the numerical aperture. Then theta naught is equal to sine inverse of NA. Then acceptance cone is twice the acceptance angle.